Let's take a look at part G. If the satellite were to change its orbit so it was now at an altitude of 50 kilometers, would it have to speed up or slow down? Explain using forces, energy, or physics that fits. Well, we got a satellite going around the Earth, and now instead of 20 kilometers, we're 50 kilometers away. So we're almost 2.5 times further out. So maybe an easy way to picture it is you think of water in a sink. As it's sucked down into that sinkhole by gravity, it's speeding up. So when you're further out, you are going to be moving slower. And that's because at a greater distance, the force of gravity that's providing that centripetal force is less. Okay? So let's look at relating these two. Force of gravity depends on G, a universal constant, the mass of the Earth, big M, the mass of the satellite. Let's do M1, M2 over the radius squared. Distance of the Earth's radius, and then we could add in the height of the satellite. But anyhow, let's look at writing out centripetal force, which is simply the mass of the satellite, call that M2 times the velocity squared over that radius of orbit. So notice the first thing that happens is the mass of the satellite actually doesn't matter, it drops out. And if you recall, a heavy thing falls just as fast as a light thing. So now we're left with just gm1 r squared is equal to v squared over r. So if we multiply both sides by r to bring this up here, this squared drops out. So we're just left with gm1 over r, the radius, is equal to velocity squared, or we can take the square root. So notice in the end, the velocity that you orbit a given planet depends on the mass of the planet. So like the moon, you don't have to orbit quite as fast over the radius here when we take the square root there. So a larger radius would result in a smaller velocity versus a smaller orbit, and vice versa. So what's interesting is, given any radius of orbit from the center of the Earth here, there's a certain speed that you have to maintain in order to maintain that orbit. So as you're closer to the Earth, you have a higher orbital speed, like 20-some thousand miles an hour. And as you get further out, you don't have to go quite as fast because the string of gravity is weaker out here and you have a slower orbital speed. So the way to think of it is, in space we got all these satellites. Why don't they crash into each other? Well, that's because they self-regulate in terms of the distance from the Earth. Now, of course, if you have too many satellites in a certain orbit, then you could have collisions, and then you have problems. But in some ways, gravity kind of acts as its own traffic cop. So it's kind of a cool way to look at it. So in a nutshell, that's part G here, looking at satellite orbit.